All right. So number six. Number six reminds me of one of the things I asked you to memorize. This one. Y'all remember that one, don't you? Of course you do. You're working diligently and memorizing those four Maclaurin series. Maclaurin series, what are you talking about? I'm talking about this. When I saw this, and I saw this kind of a situation, this kind of pattern, this kind of thing, I immediately thought about, oh, you know what that looks like? That looks like this guy. So, what do we have going on? Well, we've got the 4 in the 1 spot in the numerator. We've got the 4 in the 1 spot in the denominator. And we have the x squared in the x spot in the denominator. So what are we going to do? Well, from looking at this, looks like we get x squared in for x. And that was something we talked about a couple of times yesterday. Remember, we talked about cosine with the square root of x inside of it. We talked about sine with x squared inside of it. And that's going to go down the same way here. The tricky bit is this 4. So that 4 is the thing I need to do something with, because this 4 needs to be this 1. So how am I going to make that happen? Well, I guess I could, right? That would make 1. But then I'd have to add 3. So that's not going to work. Ooh, how about this? What if I do... No, that won't work, will it? Okay, that's not going to work. Oh, how about this? Yeah, if I distribute 4, I have 4 times 1, which is 4, and I have 4 times 1/4 x squared, which is x squared. So I don't have x squared in the x spot. I have 1/4 x squared. Oh, and you know what else? Something interesting happens. So I have this. Which means I have this. So what I have is this series right here, that one, with a 1/4 x squared in it. Okay. So I've got the Maclaurin series for 1 divided by 1 plus x. That's 1 minus x plus x squared minus x cubed plus x to the 4th, etc., etc. I'm following the pattern -1 to the nth power times x to the nth power. But I don't want to have x. I want 1/4 x squared in the x spot. So I have 1 minus, I replace x with 1/4 x squared plus 1/4 x squared squared minus 1/4 x squared cubed, and on and on. What is the nth term going to be? That's your contribution here. I'm going to pause the recording also to solicit questions. Okay, formula for the nth term here, here, and here. New problem, Maclaurin series, h of x is x times arctangent of x. What are we going to do with arctangent of x times x? Well, what if I suggested to you that arctangent of x has its own Maclaurin series, namely this one? That's a 3, not a 2, sorry. And that's a 5. Good gosh. Man can't remember a simple pattern. Sorry about that. Here we go. So you don't have to memorize the arctangent Maclaurin series, which by the way is only convergent from -1 to +1. But I want you to think about how this could fit into what we have up here. But before we get to that, I would like you to determine what the formula is for the nth term of the series. Does your nth term have an x in it? Yes, yes, it does. What is the power of x? The power of x can be written as 2n plus 1. You have a denominator, yes? Is your denominator also 2n plus 1? Do we need a -1? Yes, you better have a -1. -1 to the nth power, please. Okay. So I think it would be fair to say that arctangent of x looks a fair bit like x arctangent of x. The thing that's different is we're multiplying arctangent of x by x. And we have on several occasions looked at how we can evaluate this function or replace x with some operation on x. Well, we can also multiply by x. So what do I mean? I mean we are literally multiplying the entire series x minus x cubed divided by 3 plus x to the 5th divided by 5 minus x to the 7th divided by 7. I'm going to put it in the numerator here. Hope that's okay. -1 to the nth power, x to the 2n plus 1th power, 2n plus 1 in the denominator. We are literally saying we are going to do this. So that gives us this power series, x squared minus x to the 4th divided by 3 plus x to the 6th divided by 5. I'll give you one more here because you're going to be figuring out the pattern that works. X to the 8th divided by 7. See what you come up with for the formula for the nth term. did you write this? You do that? Okay, maybe. Did you do this? Maybe. Now, one thing you do want to be a little bit careful about is you should specify. I often like to write it in sigma notation so that it's clear to my audience what I'm starting at, 0, 1, whatever. That way there's no confusion about the accuracy of my formula. So this formula here works when n equals 0, because we get -1 to the 0, x to the second, 1 in the denominator. When n is 2, I get, or when n is 1, I get -1 times 2 plus 2 is 4. 2 plus 1 is 3. Oh, is that cut off? Sorry. Hopefully that's good now. So I think it's probably best to write it with sigma notation at some level. But I don't think you're required to. Which one of these is better? I don't know. I mean, this one's more elegant, but that doesn't make it like more correct or anything like that. So I wouldn't sweat it a whole lot. I'm gonna pause again, see if there are more questions. Otherwise, this could be the end.